Good afternoon, candidates. Good afternoon, sir. How are you? I'm fine. How are you? Today we are looking at matrices as operators, meaning to say we are going to solve simultaneous linear equations using the matrix method. Our question today is solve 9x plus 4y is equals to 17, which is our equation 1. Then 2x plus y is equals to 4, our second equation, right? Simultaneous means at the same time, meaning to say we are supposed to solve these two equations at the same time. That is simultaneous. Let's look at the stages that we go through for us to get the values of x and y. Remember, when the question says solve, it means find the value of the unknown. So our two unknowns here are x and y. So our first stage, which I'm going to name stage 1, is to form a matrix, right? So you look at this or these two equations and make sure that the x's are aligned together, the y's and those that are the other side of the equal sign. So on this one, we are going to look at the coefficient of x and the coefficient of y in both cases. Now, let's come up with our matrix. We are saying, what is the coefficient of x from our first equation? 9. So we write 9 here. The coefficient of y? 4. Make sure you take with the sign. Then the coefficient of x from our second equation? 2. So we write 2 here. The coefficient of y? 1. And what are we dealing with? We are dealing with x and y. To get 17 and 4. So now we have matrices there. So this is our first stage. The second stage, which is stage 2, is to find the determinant of this matrix, I mean to say. So find the determinant of that matrix. Can we have someone to come and find the determinant of the matrix? 9, 4, 2, 1. Stacy?
Okay, when we want to find the determinant of the matrix, we multiply 9 by 1 and then we subtract it by 2 times 4. So 9 times 1 minus 2 times 4. 9 times 1 is 9 minus 2 times 4, 8. 9 minus 8 is equals to 1. So this is our determinant.
Okay, is that correct?
Yes.
Right, so the determinant of this matrix is 1. Now, our third stage, stage 3. Stage 3 is to find the inverse. Find the inverse of this matrix. Let's have someone to come and find the inverse of this matrix. Talent.
Okay, so when you want to find the inverse of the matrix, we say 1 over the determinant and find our determinant. So it's going to be 1 over 1. And our matrix now is going to, this 9 and 1 change its position, and 1 comes over here and then comes over here. And these ones becomes negative since they are positive, and this one changes signs, which is now minus 2 and minus 4. And this is our inverse.
Right, is that correct?
Yes.
So our inverse is 1 minus 4 minus 2, 9. That's our inverse. Now, make sure when you are looking for the inverse, these two, in this case, these two, 9 and 1, like what she said, have to change the position. They exchange positions. Then these two, they change the sign. So if we had a minus there, it was going to change to a positive 4. Okay, so we are on stage 3 now, where we found the inverse of this matrix. Now, we have to move to stage 4. Right. On stage 4, you have to pre-multiply the left-hand side and the right-hand side by the inverse that you got. So you will have to take this inverse, which is 1 over 1, then we have 1 minus 4 minus 2, 9. You are multiplying it by the original matrix, which is 9, 4, 2, 1. Then x, y is equals to what you have done to the left-hand side, you also do to the right-hand side. So you are taking your inverse, which is 1 over 1, then 1 minus 4 minus 2, 9. You are now multiplying it by 74. That's pre-multiplying. Pre means before. So you are multiplying 9421, which is your original matrix, by its inverse. You do the same to your right-hand side. Multiply the inverse by 17.4. Right. So what do we get if you multiply an inverse by its original matrix? What do we get?
1001.
Right, you get 1001, which is an identity matrix. And if you take an identity matrix, you multiply it by any matrix, you get that same matrix. So in this case, we are saying if we multiply 1001 times xy, what do we get? We get xy. So there is no need for you to multiply this sign. You will have to multiply that other side, which is your right hand side. Can we have someone to come and multiply these two quickly?
Okay, so I'm multiplying these two matrices. Okay, and let's say 1, 4, and minus 2, 9, multiplied by 17, 4. Okay, so when I'm multiplying the matrices, we say row by column. Okay, so firstly we say 1 times 17 plus minus 4 times 4. And we say minus 2 times 17 plus 9 times 4. Okay. 1 times 17, 17 plus minus 4 times 4 minus 16. Minus 2 times 17 minus 34 plus 9 times 4, 36. Okay, 17 minus 16 is 1, minus 34 plus 36 is 2. Then say
All right. So after multiplying the inverse by 17.4, she got 1, 2. Therefore, x is equals to 1 and y is equals to 2. Now we want to prove. So prove, we take any of the equations above. So let's use 9x plus 4y is equals to 17. Now that we got the value of x, we are now saying 9 times the value of x, which is 1, plus 4 times the value of y,
2,
should give us 17. So we are saying 9 plus 8 is equals to,
17.
what is 9 plus 8?
17.
17 is equals to
17.
proved. So it means our answer is correct. This is how we solve simultaneous equations using the matrix method. Thank you.